Okay, my fellow statisticians, we're about to do example 1, part B of the binomial distributions. I would recommend, if you have not already, that you go back and watch example 1, part A. It's quite a spellbinder, but it does set things up really well. In fact, let's backtrack for a minute. In part A, we talked about a basketball player who's going to take 5 shots. That's N, the number of trials. He's an 80% shooter. So his probability of hitting a particular shot is 80%, that's P, and that or 4 makes failure. Missing the shot have a probability of 20%. The question in part A was the probability of hitting exactly 3 shots. So we talked about, we give a person 5 trials, 5 attempts at a task, shooting a basketball in this case. He can succeed on any 3 of them, and we don't care what order. That's why that's a combination of 5, choose 3. He's going to succeed on 3 of them, 0.8 to the third power. He's going to fail on 2 of them, 0.2 to the second power. I have to assume, based on what we did before spring break, that you know how to put that in the calculator. For the record, that's 10. So we had 10 times this turns out to be 0.2048. That tells us he had about a 20% chance. He has a 20% chance of hitting 3 of the 5 shots. Let's take what we learned from that and move on to part B. Let's make the probability distribution for the entire situation. In other words, let's fill in all of the others. What's the probability of hitting all these different numbers of shots? It really doesn't matter what order we do them. We're going to do them all. Let's look at 4, okay? So let's talk about it just like we did in part A. By the way, it's very important to notice here too that we're talking about the number that he hits, and therefore the success probability is still 0.8. All right, so the discussion here would be, Mario, I'm going to give you 5 shots. You can choose to hit any 4. It can be the first 4, the last 4, and I don't care what order. So wouldn't that multiplier out there be the combination of 5, choose 4? We'll talk about what that is in a moment. Then you're going to hit or succeed on 4 of those shots, and therefore you're going to fail or miss 1 of them. What do you think? Does that make sense to you? Yes, that makes a lot of sense there, Mr. Salamander. Thank you. I really do appreciate the feedback. All right, and I did the math on these ahead of time because, to be honest with you, this part is, and I know I'm a snob, but we've talked about this. And so if you crunch that out with your calculator, and I'll remind you that's a combination again, 0.4096. There's about almost a 41% chance he'll hit 4 of the 5 shots. All right, again, this was part A right here specifically, and now we're going to reason through all of them. Let's talk about this for a minute. The combination of 5, choose 4, if you put that in your calculator, which I'm allowing you to do, but I'll remind you there's also a pencil paper formula for it, but that comes out to be the number 5. And here's the significance of that 5. There are 5 of these sequences of 5 shots. There's 5 of them where he hits 4 of them and misses 1, ranging anywhere from hitting the first 4 and missing the last 1 to missing the first 1 and hitting the last 4. But that's the significance of that multiplier. That's how many branches. And there's 32 total branches there. 5 of them are where he hits 4 and misses 1. That's the idea there. Okay. Let's do this one. Mario, I'm going to give you 5 shots. You can choose any 5 to hit. I don't care what order. Combination, 5 shots, choose any 5 to hit. You're going to succeed or hit 5 of them. I'll remind you he's an 80% shooter. And that means you're going to miss how many? 0. That's right. You won't miss any of them. Okay? Now let's talk about this. 5, choose 5. That's 1. If you do the formula or your calculator. What is that? There's 1 branch on that tree. There's 1 sequence of shots where he hits all 5. In fact, it's the very top one. That's the only one where he hits all 5 shots. That's why that's a 1. Anyway, you do the math on that, crunch, 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 and that comes out to be approximately, well, exactly, actually, 0.32768. And again, I hope you understand it, and I would tell you, I would do this whether you're all actually sitting there or not, that once I set them up, I've learned that people they tell me, I'm good, I'm good from there. I can crunch this out in the machine based on what we went over prior to spring break. So I hope that's still the case. All right. What's the probability of hitting 2 of those 5 shots? I'll give you 5 shots. You can choose any 2 to hit. I don't care what order. Okay, that's why it's a combination. By the way, that's 10. There's 10 sequences over there where he hits 2 shots and misses 3. All right, so he's going to succeed or hit 2 of those shots. He's going to fail or miss 3 of them. Again, I'm hoping that makes sense. I'm doing all the talking. Why are you guys so quiet today? But anyway, yell at the screen. Maybe I can hear you. I don't know. But anyway, that crunches out to be 0.0512. About a 5% chance he's going to hit 2 of those 5 shots based on that tree there. But again, we can set this up now without the tree. All right, what's the probability he'll hit 1 of the 5 shots? Mario, I'm going to give you 5 shots. You can choose any 1 to hit. I don't care what order. That's why this is combination. Let me remind you once again, an alternative way to write that is this. There's other people in the world that even write it like this. I prefer the parentheses. I also want to say one more time, there's not a fraction bar in there. That's not 5 divided by 1. That's not 5 divided by 2. It's combination. But anyway, back to this. So wouldn't he hit 1 shot? And if he hits 1 shot, if he succeeds on 1 of them, how many is he going to fail on? 4! That's right. Yay, good job, you guys. This is awesome. So anyway, if you crunch that all the way out, that comes out to be 0.0064. Moving right along. What's the probability he'll hit 0 of those 5 shots? I'll give you 5 shots. You can choose any 0 to hit. I don't care what order. By the way, that combination is 1. There's only 1 branch here. It's this one, where he hits 0 shots. He misses them all, right? That's the only one right there at the bottom. Miss, 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 miss. All right? So he's going to hit 0 shots, and he's going to miss all 5. There you go. Same pattern as all the others. I'm hoping that makes sense to everyone. And again, if you push the buttons and crunch that out, that probability comes out to be 0.00032. Again, I did the arithmetic ahead of time. One other thing, if you have the luxury of having done the entire probability distribution, and most of the time you don't want to, you just pick out the numbers that fit the question you're currently enjoying. But if you did, shouldn't these probabilities, as we discussed before spring break, always add up to 100%, which I want to remind you in decimal form is the number 1. And that's a fact that we're going to use to our advantage on some of these subsequent examples, is the fact that all the probabilities in this thing need to add up to 1. And let me double check that. Let's see, carry the 1. Yeah, they add up to 1. Is that what you guys got? Yes! Good job. All right. Well, anyway, that's part B. So let's go get a cup of coffee or a sandwich or something, and we'll come back and enjoy part C here very soon. Thank you.